George, you also be recording?
Yes. Yes.
Perfect.
Good to go.
Welcome everybody to Deep Learning Adventures. I'm going to share my screen real fast. We are, let's see if this is the right one. Let's share my desktop. Okay. Probably not. No. Okay. So today we're going to be talking about a strategy for taking the AWS Certified Cloud Practitioner exam, and the studying and test itself will be discussed. If you're not familiar with Amazon Web Services training and certification scenario, here's a spread of it, and I'll go through this in a second. But if you're not familiar with Deep Learning Associates, we often look at specific courses, we work on projects, and we'll do individual competitions sometimes, and we share these via our videos, as well as notebooks and code repositories. And we also put our sessions up onto YouTube. You can find on our meetup page the presentation for tonight, as well as links to the certification we're going to be discussing. You can find the links to where we record this and put it on YouTube. And we also have a very active Slack channel, which you can join by clicking the link on the meetup. And there we discuss everything from different products, different approaches, different models, different types of concepts, and happy to interact. There's a lot more people than us that are on there answering questions and helping people. Please join us there if you want to. As I mentioned, all of our videos are shared out within a day or two on our YouTube channel, and we had a link to there, but there's many other interesting ones besides AWS. The AWS Certifications is a new series for us, and there's a playlist associated with it. So back over to the AWS certification. It's called Certified Cloud Practitioner. And from the description on AWS, this validates that you have achieved cloud fluency and a foundational AWS knowledge. And we are fortunate to have Alana, Robert, and George, who are in the process or already have their certification, present their strategy for completing this certification. The certification is foundational level. It's not required for some of the ones that you see on the right, but we believe it's a good idea to kind of have an idea of all the AWS services and how their cloud models work before we started on anything else. Ultimately, we want to get to this second one on the right over here called Certified Machine Learning Specialty. That's where we want to take on next. So this is our introductory foundational level to get to this, what they call a specialty, which is our next goal. So we'll go ahead and turn it over. Who's going to begin tonight?
That'll be Alana.
Okay, so Alana, you're going to start. Let me share here, and we'll turn it over to you.
Okay, yeah, and I don't have, oh no, I do, sorry. All right, just a second here. I'll share this window. And yeah, foundational definitely is, I think, key here. So yeah, hello, I'm Alana. And we were just gonna go through, like first off, just go through all of these modules. There's 10 in total. And these modules are like a high level overview of what services AWS has to offer. And I'm going to do the first three. And the first module is an introduction, which is brief and plants that AWS is beneficial for its core values and its services, like across the board. So to get started, I'm going to cover these pretty rapidly. So I'm not planning on clicking through this over here. Also, it's kind of like annoying the way that it shifts, and I don't want to like go into each one and then like talk as I scroll through. So I'm just going to leave this this sidebar up so you can kind of see where I am. And just side note about me, I did the whole thing. It says 51% complete. That's not true. So yeah, I'm just going to leave that up there and then talk through the first 3 modules. So the module 1, like many benefits like come up repeatedly, of course, as they introduce these services to us, you know, things like agility, scalability, pricing, focus on business, economy of cost, and things like that. So the client server model is the first practical thing for review for all of this. And the client server model, I'm sure you all are familiar, is where the client makes a request and the server fulfills the request given the proper permissions and transactional requirements. And in this, like throughout this whole course, they use the example of a coffee shop where, you know, and in this case for the client server model illustration, it's like a person simply walks in, asks for coffee, and then upon payment receives the delivery of said beverage, and then they leave. And this, so this metaphor is used throughout the whole thing and can come in useful sometimes. I mean, for me, it did a couple of times. And so then the next thing in module 1 is they go over deployment strategies. And that comes up as a beginning consideration, of course, for what type of model might be the best for your use case. They assume that people that are taking this are of course going to be using all of these services and want an idea of like generally what there is to use. So there's cloud-based deployment where all application parts run in the cloud, and you would migrate existing applications that you already have to the cloud, and any new ones would also be built there. On-premises deployment, or AKA private cloud, where you deploy resources kept on premises and use resource management tools. And then there's hybrid deployment, where you can connect the cloud and on-premises infrastructures, like, you know, for example, keeping like a legacy application on site while you use analytics or something, analytic services that run in the cloud. And then finally for the first module.
Sorry to interrupt you. I don't know if you're pointing somewhere, but we can see part of your screen. Did you want to share the entire tab maybe?
Well, this over here, I just have this here because I'm just talking through these really quickly, and I'm not going to click into them.
Perfect.
So this is just so I was just going to scroll up here as I go through.
Perfect. Okay, everyone knows.
Okay.
Good to know.
Yeah, sorry if that was distracting for anyone.
No, I wasn't sure if you were pointing somewhere we couldn't see.
Like with my hands, you mean? Or
yeah, with the notes that you were referring to. Okay.
No, I'm just talking. Sorry. No, so then.
Alana, one question I think you might, is this course free or do you have to pay for it?
Oh, thank you. It is free. This preparation course is free. The exam itself is paid.
Okay, thanks.
Yeah, no, so this is great. So like anyone that just wants to go through and familiarize themselves with any of this stuff, you can just make an account, go in and do any piece that's relevant to you or the whole thing. And so then, the last part of module 1 here, I'll scroll down slightly because I'm just talking about cloud computing in general. So they cover finally in this first module, just like why the cloud, and they are pro cloud, of course, because there's like financial efficiency. So you don't need to build or maintain anything physical. So along with that, you don't have to estimate what you may need for anything. And you can use what you need only like generally when you need it. And there's speed and agility. And this is related to the global infrastructure that you get to tap into with AWS services. So like for deployment of applications, as well as accessing new resources, which are also available globally to whoever it is that's building it. And then you can also deliver to customers quickly. And then like finally, there's like a kind of the overview of economy of resources, where also everyone can benefit from like the bundling of all of these resources that AWS has like done for everybody. And going global is doable, where also like before, maybe it would be a challenge for, you as a builder to set up something on that scale. And so all of those things are illustrated throughout like the whole course, and they definitely want us to learn specifically what Amazon services there are to like build these things, so that we can join them. And so module 2, yeah, here, scrolling a little bit.
Yeah, if I can interrupt just briefly, one thing that was really hammered home during module 1, I think, was this whole concept of value proposition in the cloud. They really want to get you thinking, why is the cloud possibly a better solution for your problem than your on-premises environment, and what are the factors that will lead to that? So for the exam, there's a lot of stuff focused on that, because it's really maybe the biggest takeaway in the whole course is just knowing when the cloud might be for you.
Mm-hmm. Yeah, very true. And so yeah, anyone, like, please feel free to interrupt if you have any questions about what I'm saying, because yeah, like I said, I'm going to kind of go through it quickly because there is kind of a lot of material to cover. And so moving on to module 2, which is longer than the first module, and it's about compute. So this is like, enter the EC2 instance, which is a major building block for AWS. And that stands for Elastic Compute Cloud. So a virtual computing environment, a virtual server that you launch, connect to, and then can use. And a few attributes of it are multi-tenancy, meaning that your instance shares with other instances physical host machines, all of that managed by AWS. And there's a hypervisor, which is responsible for coordinating the virtual machines as they share their isolated space. Another attribute is instance types. And so here's instance types, that there are different types optimized for different tasks. There's general purpose, compute, memory, storage, and then also accelerated compute, and then storage optimized. And then pricing. This is also something that they definitely want people to understand as they go in to use their resources, and how great the pricing is, because it's variable. So that's like where you always pay for what you use. You always pay for what you use, but that there are discount options, especially here with EC2 instances. So if you can handle interruptions, or if you can commit early to a minimal level of use, or if you want to reserve specific tenancy of a host or something like that, like for compliance requirements, like if your data needs to be in a certain location, then you can save money, just being aware of that kind of stuff. And finally, with the EC2 attributes, there's scalability, and that is where you begin with what you require, and you can use an Amazon service called auto scaling. And also throughout the course, as just a side note, they introduce a ton of Amazon services. And a big part, I think, of this is just knowing what those are called and where they fit. And so this is besides EC2, this is the only second one that I've mentioned so far. And it's auto scaling. So this is a service, and I'm going to say the word service a ton. And that adds to the functionality of the EC2 instance itself. So auto scaling can be dynamic, where it would respond to either changing demand, or be predictive, where it schedules instances based upon predicted demand. And there also has to be at least one instance running at all times, so it can actually scale from something. And then moving on from the EC2, I'll mention a couple other specific services here that are quite popular. There's the Elastic Load Balancer, and I'm here now. So that distributes the incoming traffic across multiple instances. So it's like a flow director for, and this can also auto scale too. So, and then after that, there's SNS and SQS, and this is touching on this messaging and queuing tab here. So these are messaging and queuing services. So this is like the order board, you know, in the coffee shop, where there's now like a buffer zone so requests don't get bottlenecked. And this separation of services also ties into an AWS recommended approach, like it's called like a microservices approach, where you know, you could try to eliminate failure of everything if one thing fails or encounters an error. And they call that monolithic approach, or like tightly coupled versus loosely coupled or decoupled. And the SQS sends messages between software components, and those messages are like fully protected until they're delivered, and then they get deleted. And then the SNS is a notification service, which can, like the SQS, send messages, but it can also send out notifications to end users about like either a single topic or multiple topics, like, you know, push notifications, for example. So EC2s let you run virtual servers in the cloud, and a serverless computing service, this is another service that lets you run code without needing to provision any server. This is called AWS Lambda. And this is like a managed compute service where you can upload code into a Lambda function, and it's an unfortunate homonym to Python function, but these connect, so the functions get connected to a trigger, and these can also auto scale, right? So if you have like 500 triggers happen, you could potentially have 500 Lambda functions, maybe less. And these are always like set to run for under 15 minutes. And then they finally, like in this compute tab, under additional compute services, touch upon some of their container services. And so I'm just going to go through these pretty briefly too. The containers, so containers are like, you know, packages of software that contain all the elements to run in differing environments. So they allow users to run the operating system from different locations like laptops, cloud, you know, wherever. And they're like a package of code and dependencies, configurations in a single object. So in this case, these run on top of EC2 instances. And so the host is the EC2. And since you can end up with multiple containers per host, of course, AWS has container orchestration services. And I'm just going to mention like 3 of them before moving on to the next module. So like Amazon, okay, so Amazon Elastic Container Service, this one deploys and manages and scales containerized applications. This one works with Docker containers also as an option. So it runs applications on a managed cluster of EC2 instances. And then they have Elastic Kubernetes service. And Kubernetes is an open source software for container application management. And AWS works with them so that their updated functionality can also be available to AWS applications. And then like finally, the last one is that they mentioned here in this module is called Fargate. And so like the last 2 that I just mentioned, those 2 container services run on EC2, and Fargate runs containers without having to manage servers or clusters. Like if you don't need to access any of the underlying operating systems or manage those hosts. So those are, so they point out at least 3 of these compute service options. Yeah, EC2 for hosting applications with, you know, access to the OS, the Lambda for short running functions without needing to manage the environment at all, and then the container-based ones that, you know, we just mentioned. And so finally, for module 3 here, where we are, this covers the global infrastructure, and it touches on that, like, you know, Robert mentioned also, like that, the reliability, this like core AWS value, one of them, in connection with the global infrastructure, and like how all of that works together. And so like AWS strives to be like many things, and yeah, reliability being one of the proclaimed values. And this So the physical global infrastructure is something kind of to understand here and like how that plays into it. So if something was to happen to a physical data center, then in order to claim like reliability, well, not claim, but to have reliability, fault tolerance, and availability, like all of those things are connected with the benefits of like well thought location planning. And so they have regions which they define as geographically isolated areas like around the world, that all of those contain multiple data centers, and they all contain their own services also, like including storage and compute, et cetera. And since the client chooses which region to use, nothing goes between regions without the user permission. And regional data sovereignty, this is like something that they say definitely consider this, means it's like subject to the local laws and statutes of that country. So since the user chooses the region, AWS recommends considering compliance and proximity, availability, and pricing, all of those things when choosing a region. And compliance, this is like always within the top two things to consider, because there could be like legal requirements or governance to consider, like if your company requires that your data is residing somewhere specific. And then proximity to customers, right? So that means the closer the user, the speedier the delivery of the content. And availability of regional services, meaning that all regions don't actually have all of the same AWS services available, like Deep Composer isn't in all of them, for example. And then pricing, of course, some regions are cheaper. And then within those regions, there are availability zones, which is either like a single data center or a group of them. And the point there is to physically distance centers like tens of miles apart in case a disaster happens. So they're close enough to have low latency together, but then far enough to reduce risk if one goes down for whatever reason. And I'm almost done. I know I'm talking kind of quickly, so I'm sorry about that. And then like finally in this module here, there's edge locations, and these are so edge locations store cached copies of the content so that they're closer to customers for faster delivery. And this is kind of fun because this failed me when I was trying to review this material yesterday. I got like a 504 error telling me that to refer to the CloudFront documentation, but that was exactly what I was trying to look at online. And CloudFront is a content delivery network service that stores the caches to local edge locations. And so besides CloudFront, they also run a domain name service called Amazon Route 53, which helps direct people to the appropriate web locations with the lowest latency. And so in general, like access to all of these AWS services are via API calls, like launching an EC2 instance, for example, and those can be done through the like AWS management console, like the GUI, or the AWS command line, or AWS software development kits. And of course, they have their own environment management tools. Like there's two of them that they mention, at least in this module. There's one called Elastic Beanstalk, where you supply code and configuration settings, and then it deploys what is needed for you. And then there's one called CloudFormation, where you define what resources you want to use, like as a template, and then it will start provisioning whatever is needed, like in parallel for you. And so that's what I've got for the first three as like an intro to that content. And so Robert, if you were there, I can pass it off to you for module 4, which is network.
Can we take a pause and see if there's any questions? Thank you, Lana.
Yeah.
I don't think we had anything in the chat that's unanswered. So
yeah, I know this is a lot of information, but all we're doing basically just giving you an overview of the different topics that this training material covers. And then in the end, I have a few slides of presentation that summarizes everything that we said and kind of gives you an idea of what to study in what order and how to prepare for the exam.
Yeah, keep in mind that the recommendation, I think, is for people to study something like 20 to 30 hours. 20 if you've got experience with AWS, maybe 30 if you have less. And we're going to try to condense it all down to the Cliff Notes version in this session. Can you unshare your screen?
Yes, of course. There you go.
Thank you.
The course that we're going over happens to be expected to be 6 hours. So you can see there's a lot of other things to study.
What course is that?
This one.
Let's see. I think I may have shared the wrong window. So do you see the AWS Cloud Practitioner Essentials now?
Yes.
Yes.
Okay, awesome. So Module 4 is on networking, and it covers the basic concepts of networking. Talk about public and private networking resources, a number of different gateways, virtual private gateways, internet gateway, NAT gateway. It was not in the course, but is kind of important. Virtual private network, and then just some various topics related to networking. So there's really 3 concept modules here, or units. I guess they're using the word module to describe these outer ones. There's 3: connectivity, subnets, and global networking, and then there's a summary and a quiz at the end of each section. So the first one here, connectivity to AWS. That one is really about various types of ways to get network traffic in and out of AWS itself. And there are a lot of helpful analogies here. The coffee shop that Alana mentioned earlier is a go-to example in this course, and they reuse it a number of times. And I find it to be a very helpful picture because it puts some of these cloud concepts into a physical brick and mortar analogy that tends to make a lot of sense for some of the operations they're describing here. So for the networking, what a lot of we're going to talk about here is how you're allowing traffic in and out of the network. And so the obvious analogy is with doors and roads and streets and various security controls at the entrances. So they start off by saying that for the coffee shop, we have a location in a city, perhaps, and you're going to need a couple of different types of resources for your coffee shop, and you want some of them to be public-facing and others to be private-facing. Public-facing is going to be things like your doorway, your seating area, and obviously the service counter. And the private-facing is going to be something like the baristas that are brewing the drinks and any backroom storage, something like that. So they then talk about the internet gateway being the front door to the coffee shop, the virtual private cloud is a cloud that can have multiple subnets. Some of them can be public, and you can have public subnet and a private subnet. A typical configuration, I guess, would be to have one public and one private subnet, but that's there's many ways to configure your AWS resources. The virtual private gateway that they go around and talk to here then is a bit of a private entrance to the shop. Maybe it's a back door that only the employees can use. And then they go into the virtual private network, where Here you're actually encrypting traffic that's coming into your coffee shop, and you're doing it along the route in. So perhaps this is offering a private bus service for your customers or for your employees to be taken from the center of the city to your business. So you have to show your credentials before you get on the bus, but once you're on the bus, they've already verified you, so you can walk right through the door. But the traffic is also encrypted, so I guess we can think of that as being a bus with very dark tinted windows or something, so you can't see who's on the bus. Then they go on to say that, well, this virtual private network is great, but the bus can also get stuck in city traffic that has nothing to do with your own business. And then they introduce the concept of AWS Direct Connect, which actually allows you to establish a dedicated private connection between your center and a VPC using actual hardware. So in this case, this is not just the city street with the bus on it. Now you've actually built a tunnel that's a private tunnel that only you can use. In the next unit, we go and talk about subnets and network access control lists. Here, we're really talking about the security of each resource and how you decide whether to let traffic in or out. So when you think about that virtual private cloud composed of one or more subnets, each subnet has its own security. And in this example here, let's see, yeah, here they're just saying that the virtual private cloud is only allowing public-facing traffic to come to the public-facing subnet. The cashier represents the public-facing subnet, the barista representing the private-facing subnet. You don't want your baristas to be distracted while they're attempting to concoct the best drinks. So you just prevent the customers from shouting at the baristas while they're attempting to do their jobs. And for a more computational example, then we actually talk about public subnets. You may have an Amazon EC2 instance that is being used as a public-facing, say, a website for an online store. And the private subnet here may be the database of transactions, either the person's past purchasing history or other information that they're not going to be showing to the public directly. And then we have to figure out how to manage network traffic within a VPC. The course talks about two ways of doing that. You have an access control list, which operates at the subnet level, and you have a security group that can operate at the individual instance level within a subnet. So there's different protocols that these control measures follow. The network access control lists, the example analogy they give is like a passport control officer, where they're stateless, they don't remember anything about past interactions, they're just looking at your passport and deciding whether or not to allow you into the country. The instance level security groups are a much more local security measure. So okay, we'll go in this. Here's the passport control officer example. Need to check with that person as you're entering the country, and you need to check with them on the way out, I guess. So you can't, all incoming and outgoing traffic by default is monitored by the network ACLs. The security group, as I said, is the more local virtual firewall that's only looking at a specific instance. And by default, the security group actually denies all the inbound traffic, so you have to configure it to allow outbound. But once it does, you can do stateful packet filtering. And in this case, it's sort of like the bouncer at a bar or a door attendant or something, where you might say, okay, I'm leaving, maybe stepping outside to take a call or a smoke or who knows what. and the person remembers you when you're going right back into the building. Hi, I'm Beck. I remember you. You can go ahead without having to show me your ID again. And the last section on networking, global networking. This is where they talk a little bit more about Amazon Route 53 and domain name system resolution services. And here the idea is that Amazon instances can be running just about anywhere, but the DNS server is needed to help direct traffic to the right place. So the example shown here is you may be using CloudFront to stage your resources. CloudFront, remember that we just learned from Alana, was being used to deploy content to edge locations that may be closer to users, so to reduce latency. Amazon Route 53 is kind of like the lookup table, the phone book of the internet, and it's going to tell you, based on what you're looking for, this is where you should go to get it. So it routes you to the correct CloudFront server. And that's it for Module 4. We'll move on to 5 unless there are questions.
Nothing in the chat. Seems good.
All right. 5 is a long one. It's storage and databases, and there are copious options to do these things in Amazon, and they want you to know a little bit about all of them. So they go into some detail on a few of them, and then there's a summarize various services that are thrown at you at the end of the module. So at first, we learn about instance stores and elastic block stores. And here, what you're doing is looking for very temporary storage that can go on an instance itself. And it is block level storage, and they're saying here it's behaving like a physical hard drive, but it's a little bit less like cloud storage in the sense that it actually is physically attached to the host computer, and when you terminate the instance itself, you would lose any data in that store. So one way around that, where you can still do block level storage. Block level storage, by the way, allows you to access individual blocks within your files or within whatever you're storing, so you can easily modify small segments of it. That you would do here with an EBS, Elastic Block Store Volume. And if you put one of those on your instance, now it is capable of persisting beyond the life of the instance, but it's still just local to wherever your instance was. So you're going to want to back it up because it's data that you probably want to persist. And so you'll take snapshots. Conveniently, the snapshots are only measuring data that has changed. So if you have an enormous file and you only change a few lines, then the snapshot can be a pretty quick process and doesn't take very long. The next storage option they introduce is a simple storage service, or S3, which many of us may be familiar with. This is their most basic object storage mechanism. Object storage being storage that is accessed through a key, and typically think of it like storing a file, maybe a video, an image. It's going to have a way of identifying what the file is. Maybe it has some metadata telling you the frame rate of the image or the resolution, or frame rate of the video or the resolution of the image. And then the majority of the size is data. And one of the differences between S3 and these elastic blocks is that the objects are written as individual units. So in this case, if you want to modify a very small part of that object, you actually have to write the whole thing again. So
Robert, sorry, there was a question on the block store, whether it was hash addressable.
is the block store hash addressable? I don't know.
You can look
Okay.
it up while we talk. Don't worry.
Sure. So let's see. We were talking about S3. Could be objects, and specifically you're going to use it when you want quick access to objects, but they're typically things that you're going to write a small number of times, maybe read many. There's an acronym, write once, read many, WORM, W-O-R-M, that is described for this concept. And S3 is typically a good choice if that's your model. Think of a static website. Those are often served using S3 storage. In the S3 storage section, we have a number of storage classes, and these are all covered in the material and important for the exam. And there's a little bit of information on each one of them here. Standard is kind of the standard rate, the highest priced one, I think. Stores data in a minimum of 3 availability zones, so it has the chance of losing it is something like 1 in 10 to the 12, 1 in a trillion. 11 nines is something like the number they were using for the reliability. Standard infrequent access has the same reliability, so it's stored across these 3 different availability zones that are spread out in different, not different regions, but different geographic areas within a region. Standard infrequent access allows you to pay a slightly different plan where you pay a little bit less to store it and a little bit more for retrieval. And this can be a useful thing if it's something that you don't expect to access very often but need it immediately and reliably when you do. Then there's another cheaper zone yet, which is 1 zone infrequent access. So infrequent access, but also you're storing data only in a single availability zone, which makes it a little bit more susceptible to natural disasters, power outages, etc. And so this might be a good use case if it's something that you want to store cheaply, and especially if you can easily reproduce it in case that AZ fails. Intelligent tiering, that's another storage class with really just allowing you to pay a little bit up front, automation fee, and it will automatically decide which of these storage classes is cheapest for you in exchange for that monitoring and automation fee. And then for deeper, more archival type storage, there's this Glacier, aptly named, which is low-cost data storage, and it's really designed for something that you want to keep, but you're not going to use it very often, so you don't care too much if it takes a while to get it when you do need it. So this might be archived customer records, and they give you some specific examples. You can retrieve the object within minutes to hours. And then there's even another deeper level yet, bottom of the iceberg, I guess, if you will, Glacier Deep Archive, and you can retrieve objects from that within 12 hours, and that is the cheapest storage option on Amazon S3. Another storage option that they go over is Elastic File System, and this has a lot of the same characteristics as the Elastic Block Store, except it's a file system. And the good thing about this one is that you can have many users interacting with a file system, and they can all be making changes independently of one another. And the system is able to make those changes quickly based on the way it's implemented in blocks, so that everybody can see the current state quickly. We'll move on to databases, which is the second half of Module 5. And Amazon RDS, Relational Database Service. So many of us may be familiar with databases, but relational databases are perhaps the most canonical form of database, the one that you're most likely to think of, the one that you're most likely to learn when you first start in databases. And you can think of it as a table. You have columns and rows. Typically a row is an object, and a column is a particular type of field that you're trying to store about that object. And these are databases that are using structured query language. They're formatted so that you can use SQL to either insert, delete, or query the existing data. So this is what you call a row store, meaning that the items here in one row tend to be stored together, and then you add another row and that'll get stored together. And so one of the things that's important to understand about the database services that Amazon offers is that you will have, even of the relational databases, there are row stores and column stores, and either one may be optimal depending on your use case. So with the row store, the rows are all kind of stored together. You can guess that this was going to be something that's useful for if you need to do a lot of transaction processing, a lot of inserts, a lot of updates, creates, deletes, where you're saying, okay, I'm going to remove this coffee from my menu, or I'm going to remove this user from my database. You're going to be able to quickly insert because all the data that's in a row is in the same place. Contrast that with a column store, which you might have all the sizes in one place, all the prices in one place, which makes it very convenient to do big data calculations on that one column to vectorize those operations. But it then comes at the cost that the data are more spread out. If you want to delete or insert a single row into the database, you have to then put the ID one place, the price somewhere else, the size somewhere else. So this goes to the notion of what is it, OLTP versus OLAP, online transactional database, or online transaction processing versus online analytical processing. And these are important to know for the Cloud Practitioner exam. The Relational Database Service, RDS, and Amazon Aurora, which is the enterprise class relational database that they show down here, and these other ones as well. These are all row stores. And when we get down 2 more units, Redshift is the most prominent column store. So there's going to be different use cases for those two. Before we get to Redshift, though, there's a unit here on DynamoDB, which is a NoSQL database. And it's a non-relational database, so you're not typically going to be using SQL, called NoSQL database, but we'll look at seeing what that data looks like. Here we have data that are stored by key and a number of values. So we no longer get this nice tabular format. And it may be a little bit inconvenient to access all the addresses, for instance. Because in order to get that, you have to say, find key 1, address. Find key 2, now find address. Find key 3, now find address. So in the key value store, however, it's lightning quick to get a single full object, right? Because just finding one key is very easy. So pulling that one object, this is really what the use case for the NoSQL database is optimized for. And they talk about single-digit millisecond performance to access those objects. The next unit down is Redshift, as we just discussed. They also call it data warehousing, but it's the columnar store that we mentioned earlier. And you're going to use this for especially analytics of really lots and lots of rows. Maybe you're accumulating them over time, something like IoT, Internet of Things, database, large time series databases. Those might be a good place to do analytics in Redshift. They also talk about database migration services. It's exactly what it sounds like. Migrate your database. Might be useful in cases where you want to, obviously, to migrate your database from on-prem to the cloud, which is one of their use cases. But they also talk about how you can change the structure of that database. So for instance, if you have a row store and you want to turn it into a column store for Redshift, you can do that using this database migration service. It's a very convenient tool for for performing those kinds of operations. And at the end of the database services section, lots of other stuff which is useful to know by name for the exam. Just know kind of what they do. Document DB for documents, Neptune graphs, Quantum Ledger is a ledger database. Do it for a complete history of all changes. Blockchain, Elasticache adds caching layers on top to, if you have certain requests that are really common, you can embed these caching layers on top of your database to make those retrievals quicker than they would otherwise be and optimize performance overall. And then you have something similar for a Dynamo DB accelerator, which is an in-memory cache for the NoSQL database. Any questions on Unit 5?
Looks like we're good.
All right, Module 6, Security. Here we learn about the AWS, well, look at the introduction first. The shared responsibility model. This is a super important thing from this unit. Multi-factor authentication, highly recommended. Identity and access management, IAM security levels. And then we learn a little bit about organizations. We learn about security policies, a little bit about denial of service attacks, which is an important thing to think about with AWS. Or maybe not so much an important thing for customers to think about, but a selling point for them. So that's why it's in there. Shared responsibility model. So there's a lot of language around big words like responsibility here, but it's really just telling you that the security of your own data within AWS is a two-way responsibility. AWS is responsible for some of that, and the customer is responsible for other things. And again, the analogy to brick and mortar facilities comes into play here. You can think that AWS is a little bit like your home builder. If you want a secure home where people are not just walking into your house all the time, you want the builder to have provided you with a solid foundation and walls that people can't just knock over. On the other hand, once they have sold the home to you and you control the locks and keys, it is your responsibility to actually lock the doors and windows when you're coming and going. So that is the analogous to the customer responsibility up here. So they go ahead and talk about various things here. In this diagram, you're looking at very global, large things in the bottom, and it moves just to different layers throughout here. So you're moving from Amazon being responsible for the security of the infrastructure and any software that they're providing. Remember, you can run a lot of services just as in a completely serverless way, where Amazon maintains all the software and patches those systems. But you can also run your own container services or other operations on ECS on EC2 instances, where you'll have more control and you may be responsible for patching those services. So it's just an overview of what aspects of your own data security are you responsible for, and what aspect of your data security is AWS responsible for. User permissions and access. This is a pretty big unit here. Identity and access management. You just want to understand what are IAM users, groups, and roles, and how are policies used to control their permissions, and a little bit about multi-factor authentication at the bottom of this one. So when you create an AWS account, you're going to have a root user. You're going to make a root user, and the root user has all the permissions it can have. Generally, what you want to do is spend as little time using that root user as possible, because anything that you can do while you're not root, you're more secure doing it as not root. Because with great power, with the root user, becomes a little bit more vulnerable to any security concerns. So once you've created your first IAM user and you've given it permissions to create other users, then you can get out of root for the most time and only use root when you really have to. I think there's certain account billing and other setup things where you have to be root, but the vast majority of actions you can do on AWS not being root. Users, this is typically an individual. So maybe you're operating a business, you've set it up, you've created the root account, created user accounts. User accounts are probably the people that are your employees interfacing with the system. Maybe employees, maybe customers, depending on what your service is if you're offering software development services. Users, typically you'll have, you can assign different permissions to different users. You want to make a different user for each person. Policies here, these are JSON documents, basically, that tell, translate this as what resources is any individual user or group or role allowed to access. So in this example, they're talking about you can list object or get object and a specific bucket ID that you can go to. These policies are all established through these little documents here, and you can do them for individual users, but if you have a lot of users, that can get inefficient, especially if you want to change them. So there are a number of ways you can manage your people, and you can do that with groups, combining a number of users into a bucket where just assign one policy to every user in the group. So you have a cashiers group here. All the cashiers have access to the cash register, but they don't need access to some of the raw materials for making the products in the back. And then you might have a situation where you have multiple employees, but the employees themselves may migrate from one role to another over the course of your day. So here you might have some person who's a cashier for a while and a barista for a while. So you can assign a user can get various roles, and then they have to check out a role, and when they check out a role, they get different permissions depending on what role they check out. So you just get a bit of a configurable, agile way to manage your user permissions with roles. Multi-factor authentication, nothing really unique to AWS about this. It's just a good security practice in general, and AWS encourages it. AWS Organizations here, really just a way to manage multiple AWS accounts. I think there's a picture somewhere on this one. Yeah. You have multiple groups here, finance, IT, HR, legal. Maybe you want to give certain ones the same permissions. So here you're saying HR and legal might have similar, need to access the same services and resources. So you might put them into the same organizational unit. So organizations is just a way of organizing the business. One thing that it does allow you to do is consolidated building, which is not described here, but I think George will get into that in the billing section. Compliance, another thing that they want to highlight. AWS artifacts, and this is definitely emphasized in the course and in the exam. You may need to uphold specific standards. What is here, it's a service that immediately provides any inspector or compliance investigation what AWS is doing to ensure that your company meets whatever compliance standards it needs to meet. This is all related to the AWS portion of this shared responsibility model. Denial of service attacks is the last big unit in security, and here a number of, again, real-world physical examples. Customers calling this coffee shop, but maybe it's a prank caller that keeps calling back, and if you're trying to service that customer, you're going to end up compromising your ability to serve other customers. So there's a number of approaches that Amazon takes to combat this, And you can think that the business model of Amazon, the very nature of being cloud and so distributed in its ability to provide the services, is already another layer of protection, or at least just making it that much more difficult for adversaries to conduct these denial of service attacks. We go ahead and talk about a few different types. Distributed denial of service attacks. This is not only as you have one person pranking the business, but now you have a whole bunch of different people, and you can't necessarily block one single IP address. For the distributed denial of service, Amazon actually offers a service that is focused only on protecting against DDoS. They offer standard, I think, is free or complimentary with whatever AWS services you're offering. And advanced is an additional paid service where you can get detailed diagnostics and other stuff on top of the standard level. And the video in here describes a whole bunch of, lots of more examples actually. This was a very in-depth video. Additional security services, key management service for encrypting data in transit, AWS web application firewall, monitoring network requests, inspector, guard duty, just a few other resources to be aware of. Each of them does different functions that your paid services on top of the basic Amazon services. And that's the end of Module 6. Questions on 6?
I think we're good.
I think I'll turn it over to George.
Cool. Thank you, friends. Let me share my screen. I'm gonna use actually some just one slide from this presentation that I shared. Can you see my browser?
Yes.
Perfect. So in this presentation that I shared with you, we're not going to talk a lot about the exam itself. I'm going to do that next week, but we have a slide here with different resources, just to give you a broader, a bigger picture of what we're doing. This is one of the resources that we use to pass the exam. So this is what we're going through, this AWS Certified Cloud Practitioner. There are a few more other resources that I'll go in the end after we cover the first one, so that you have a better understanding of how to best prepare and what material is out there. Okay, this is just to give you like the bigger picture. So yeah, thank you, Elena, thank you, Robert, and thank you, David, and everyone for asking good questions. So we covered first 6 sections, which to me are core sections. And then the next sections, as you'll see, get more into how do we, once we have infrastructure in AWS, how do we monitor it? How do we get an idea of how much it's going to cost? And how do we actually, if we have a bigger project at hand, how do we migrate our infrastructure from on-premise to the cloud? So 7 talks a lot about monitoring and analytics, and specifically talks about some really useful AWS services called CloudWatch, CloudTrail, and Trusted Advisor. Just to give you a very basic idea, CloudWatch, anything that has to do with metrics or logs, CloudWatch is the service that you're going to use. So by default, multiple AWS services log metrics to CloudWatch, and you can head over there. You can see the different metrics. One thing that CloudWatch can do, among other things, apart from just monitoring, let's say, your CPU utilization or your memory utilization or your storage utilization, or how many reads and writes you're doing, you can also set what are called like threshold or alarms. So that, for example, if your CPU utilization, your CPU instances is crossing that 80% threshold, you can do 2 things. You can either get notified, or you can actually do some kind of action. Maybe you can spin up new services, or you can do something else. You have a lot of control in terms of how to react. That's CloudWatch, anything to do with metrics. On the other hand, if you are using an AWS account, chances are that you are sharing it with other users, and you'd like to know or have some kind of detailed log of what happened at what time and by whom. Some kind of like accountability service. And CloudTrail is that. It records every transaction that takes place in your AWS account, and every in the end of the day, everything is basically an API call. So this is, think of it as a large ledger of all the different API calls. So for example, you can look at who logged in at what time, which user, and what service or what request they made. So what happened, who made the request, when did the request actually take place, and how was it made? Was it through the console? Was it through an API? Was it through a service? And so forth. CloudTrail also has a feature. You'll see that several services have like a core functionality, but they also have an additional functionality that gives you extra features. Like one of them is this insight feature in CloudTrail, where it can detect what is called unusual API activity. So for example, if you've never used, for example, maybe a blockchain service, but and all of a sudden you get all this API requests, maybe that's a unusual API activity. Cool. Moving to Trusted Advisor. This is, if you go to the website, actually, and I highly recommend when you go through this material, to check the actual services web pages. There's a quick video there that basically explains in a little bit more detail, but Trusted Advisor, this depends on your plan that you have. We haven't talked about plans yet, but there are 4 different types of plans that you can subscribe to in AWS. And based on that, you get a report that checks your AWS account and tells you, it breaks down its findings into 5 categories. Things where you can save money, cost optimization, things where you can do better in terms of performance or overutilization or underutilization, things that are maybe need your attention as a security personnel, or things that maybe are not configured to be fault tolerant. In other words, if something fails, your application might not be able to keep up service. And also the limits. Are you actually running your services so much that you're actually crossing or reaching those AWS limits? There are some default AWS limits. You can always contact support if you want to extend that. So this Trusted Advisor, based on the plan that you have, you can either do it on demand, if for a basic plan, like you log into the console and you do, okay, give me an assessment right now. If you have more of the high-end plans, this is actually executed for you automatically every week, and you get a report. You can actually customize who is going to get different parts of the report. So for example, if you're part of a larger company, maybe you have a dedicated team for security, you can route or forward that report's finding to your security team. If you have some, if you have a team for billing and cost and all that, maybe that can be routed there. So that's the monitoring and analytics part. We didn't cover a lot of analytics in it. And then let's go to pricing. So now we've heard a lot about services. You've heard a lot about benefits of the cloud. At the end of the day, you want to make a decision, right? And you want to make a decision, A, for moving to the cloud, and B, for staying in the cloud, and how much will it cost me over time? And this is where AWS has a lot of services that give you a very good understanding of your current infrastructure. Also gives you an idea of if you want to expand to new services, how much that would cost, and many other great features. So there was a discussion in the chat. Can I try it? Do I get credits? Yeah. So when you sign up with AWS, I think you get some credits. It used to be dollars of amount, but now it's basically on operating hours. So for example, if you use a specific service, you might get a specific compute budget, or if you use a storage service, you might get a specific storage budget for free. And the pricing is broken down into 3 categories. It's always free. It's free for the first 12 months since you open an AWS account, which is tricky because you might open an account now, but not really use that service for 6 months. You can always use new AWS accounts, so that's always an option. Or what is called trials. Your trial is something maybe for a week, or depends on the service, a month or a few days. And if you like it, you subscribe. If you don't, you don't use it. So the flexibility that the cloud offers is that you really pay for what you use, and some services you are charged by, for example, for compute services, used to be that you were charged by the hour, then it broke down by the minute, then it broke down by the second, then it broke down by millisecond. So the granularity is really, really, really high. There are services that if you reserve them in advance, you can get a lot of discount. One example of here is like the compute services. So if you know that you have, for example, a specific amount that your CPU utilization will be at, let's say 80%, and you know they're going to use this EC2 instance for the next year, then you're going to save a lot of money by reserving them. On the other hand, if you have anything related to on-demand jobs, like if you want to do something on the fly and your application can tolerate and disrupt, you can use what is called spot instances, and those are like extremely low cost. But then again, the price of them is not fixed. It's based on demand and supply. Basically, AWS in the end of every minute or every hour detects how many unused capacity they have, compute capacity, and they offer that to users. Some services, for example, like S3 services, like storage services, you get a different, you get charged a different ratio for how much data you have. So if you have a little bit of data, maybe you're paying, let's say, X dollars per gigabyte. But then if you have way more, you get that X decreases. So basically you get some kind of discount for volume. So this many of you might have a lot of questions. You might think, okay, now can you give me an actual number? How much would it cost me if I use, let's say, very basic EC2 with some S3 and maybe a DNS service or something else? So AWS offers what is called this pricing calculator. And there you can specify what region you're going to use. Let's actually check it out. So what region you're going to use, what service you're going to use, what type of service or what type of instance and so forth. So let's see. So different regions have different prices for economical reasons, and each service might have different settings. So for example, you might need an estimate of how much data you're going to store or how many queries you're going to do. And so let's say I will do, say, 10 queries a day, data amount scanned per query. So this depends on how much data I have. So let's say I have maybe 10 GB. So at the end of the day, a monthly average would be about $14 if I wanted to do some kind of ad hoc analytics. Athena is basically an SQL engine within AWS. You can query data out of S3 directly. So you can do this for any other service, and you can get an idea of how much it costs you on a monthly basis. So these are some examples. So yeah, and some of them offer some free requests. So for example, with Lambda, which is a serverless service, you get 1 million free requests every month. Yep, and 3 million seconds of compute month. And then when you get the invoice, or you get the price breakdown, you can see that based on the region you have, how much you use for compute, how many seconds did your Lambda spend in computing, as well as how many requests did it receive. Maybe it's receiving from like something like an API gateway, or maybe it's receiving it directly from the internet. So that's for Lambda. EC2 also has similar or its own pricing, as well as offerings, as well as S3. So with S3, you're not just paying for, or actually this is true for many services, especially if they have input and output. You're not just paying for compute or storage, but you're also paying for how much data is coming to the service and how much data is leaving from the service. So for example, S3, you might have very few files, but if you end up moving those files in and out of S3 you might see an increase in price there. Right, so get put requests basically out of S3 are tracked. It's
Hence
not
the
just
reason for the 6 different levels of service. Some
Right.
of them charge you more for the put and get requests, and others charge you more for the just to have the storage.
exactly. Yeah. So in some of them you pay a lot for storage, but a little bit for I/O. In other ones you pay not almost close to nothing for storage, but a lot for I/O. Like Glacier, for example, is very cheap to store, but it's very expensive to do I/O because internally they have their own systems to back them up. But for something like S3, they figured out that okay, we want to prioritize I/O and a little bit pricey compared to other services storage. But in the end of the day, it's pretty inexpensive. I've rarely got any charges for S3, maybe a few cents, like depending on your volume of data. Then you can look at this there's a nice billing dashboard that gives you a breakdown of everything. And the other thing I wanted to quickly touch upon was this idea of multiple AWS accounts. And actually AWS highly recommends that you create multiple accounts even within the same company. So you might have an account for different departments, for HR, for finance, for IT. They highly recommend that each one of them has their own account. And you also have what is called a head account or a primary account. And that is responsible for managing all of them. And you do that through AWS Organizations. So one thing that you can gain from that, apart from managing all these multiple accounts, is what is called consolidated billing. So at the end of the day, only this primary account gets one final bill. It will be broken down by different accounts. You can even look at the different services that each account used. But in the end of the day, maybe this account is only responsible, let's say the CIO, for the entire AWS infrastructure in the company. The other thing is if different accounts use services at different ratio, individually, they might not be applicable, or they might not qualify for any high volume discounts. For example, for S3, as I mentioned, the more data you use, the less you pay per gigabyte. So individually, they might not qualify for some kind of offering, but if they're combined, you might cross those thresholds, so you might get that discount. Cool. Quickly then, the other thing is you can have a breakdown of, you can set up budgets where basically you can say, I like to spend this much money this month. This, you'll get a breakdown of what is the current cost, what is your budget cost. You'll get another one that's basically a forecast of your usage by the end of the month. So you have an idea of where you are with your current usage compared to budget, and where is your forecasted usage compared to budget. Cost Explorer is also a nice feature. You can get a breakdown. This is basically a user interface of your costs, right? So you can get a breakdown by time of the different services, maybe by availability zone, by region, by you name it. You can see here different options. You can also export this and share it with others. Cool. The other thing is, based on your account, you will need some kind of support from them. And they offer 4 basic support plans: the basic, the developer, the business, and the enterprise. And as you can imagine, they vary both in cost, but as well as features that you're offered. So with the basic, you get, it's free for all AWS customers. You get basically white papers, documentation, and maybe some support in terms of communities, but you don't really get any anything else. You also get limited features in terms of, I remember those 5 checklists that you can do with Trusted Advisor. If you need something more, then you can go to the developer. It offers support as well. Like if you need an architecture support, like it's like a solution architect to guide you how to develop something, it comes with developer support. If you need more than that, you can get even support for third-party software, or you can get all the features from Trusted Advisor. You can use the business one. and the enterprise one has everything. Plus you get what is called a technical account manager. And the AWS support has a nice page here that kind of summarizes the differences. One thing that I'd keep in mind, there were some questions here about the exam, and you need to know a little bit about, for example, if you reach out to the support team, is there any service layer agreement that I should expect? What is the response time and so forth? So here, there's a breakdown here for like general guidance. So when you open a case with AWS, you are required to specify what is the severity of your case. Is it general guidance? You're just asking questions. Is your system impaired? Is your production system impaired, or is your production system outage, is having an outage? And based on different plans that you have, the SLAs here are different. So the higher the plan is, the quicker you get a response. And obviously more features and pricing as well, as you can see, changes. Cool. Let me go back. The other thing is, let's say you scanned the ecosystem of AWS services, which at this point I think is about 160, 170 services, and you didn't find exactly what you needed, or maybe you like an offering that a company offers. So maybe tomorrow Deep Learning Adventures is building, let's say, a module, and you want to offer it as a service or as a product. Then AWS has what is called a marketplace, which is basically a collection of third-party services, products, consultation, hardware, software, you name it. So you can find things, anything from DevOps, data analytics, infrastructure, security, machine learning, and so forth. And that's the marketplace. Cool. So that's 8. It's a long one. It has a lot of content. I quickly go over 9. 9 is not that long. Are there any questions before I go to 9? I didn't see anything in the chat.
Nothing.
Okay. So 9 actually talks a little bit about how to actually migrate to the cloud and what options do we have. And they talk a little bit about this cloud adoption framework, which is basically how do we break down this complex project? We have, let's say, multiple servers on our in-premise, multiple applications, multiple teams, as I mentioned before. For example, I have HR, finance, IT. How do we actually migrate them to the cloud? And this framework breaks it down into 6 different steps, all the way from the first 3 are basically what happens within the organization in terms of business, people, what training we need to do, who needs to be involved, governance, what are new processes that need to take place, to the actual implementation of what platform, what service do we need to use, how do we make sure that they're secure, and how do we make sure that they're up to date, we don't have any disruptions, they're highly available, and so forth. So this journey is broken down here by these 6 perspectives, and yeah, it's good to know a little bit of some of the keywords, because as you'll see in next week, we'll talk about this. We got specific questions about them in the exam. Then what is the migration strategy? Let's say you're going through that process and you're tackling this on an application level, so application by application. You have basically 6 options. You can rehost it. Actually, there's a nice visualization here that I think will be more appropriate. So you discover your applications and you prioritize them, which is the most critical to your organization. Let's say something that that HR does is the highest priority. Okay, then do you need to determine it? If that is probably something that needs to maintain on-premise, then you retain it, you don't move it. Or maybe something that you need to decommission, let's say, in a few months, and there's no need to migrate in the cloud and decommission it there. So then that would be another option to retire it. Then the other one is, okay, we need to actually move it from on-prem to the cloud. And this is where you have this rehosting, where usually you're just moving it. For example, if you have a NoSQL database and you're in-prem, you can either use the EC2 plus MySQL combo, or usually just use the RDS service that AWS offers. What if you want to tweak it a little bit? Then you have this replatforming. Maybe MySQL is not the best option. Maybe you want to use some kind of like serverless database, like Aurora now offers something called serverless Aurora. You don't have to worry at all about the size of your database and the I/O and all that. What if you want to repurchase something? Maybe you're subscribed to maybe like a Salesforce account or some other third-party account. How do we do that? And the other one is refactoring. Maybe you have like a large monolithic applications, right? Maybe it involves multiple steps. How do you break it down? How do you find the appropriate services in AWS that meet your demands, and how do you put them together, and how do you test it? So this is more on the solution architect, and software development side, where you actually have to break down a large application and build it from scratch with AWS services. So once you do that, you validate the new service, you have a transition plan, and then you go into production, and that should do it. Cool. Now let's say in terms of data, you did this, but you have gigabytes or terabytes or petabytes of data on-prem that you want to move to the cloud. Obviously, the internet is one solution, but as you can imagine, A, that is slow, and B, you might have some kind of compliance or security reasons not to do that. So this is where AWS Family comes, and they have the AWS Snow Family that comes. They have 3 or 4 versions. They keep coming with new ones every now and then. They have a small one, a Snow Cone, which is basically like a USB stick. Let me see if the actual website has an image. Yeah, it's a little bit bigger than a.
Yeah, those videos are pretty good too, because they show you people interfacing with them, get a sense of the size.
So you can start with Snow Cone. Has what, 8 terabyte of storage. If you want solid state drive, it's 14 terabyte. It actually comes with its own CPUs as well, 4 CPUs and 4 gigabytes, and no GPUs. You can use something called storage optimized, which gives you more storage. Then you can use the edge compute optimized, which is on the compute side has way more CPUs. And if your data doesn't fit any of this, by the way, this Snowball is actually the size of a suitcase, both of them. And the Snowbill is actually a truck that comes to your company. So you have, let's say, petabytes of data, and you have high regulatory or compliance reasons to do that, then you need this solution. Cool. So yeah, Snow Cone, Snowball, 2 flavors, storage optimized or edge or compute optimized, and Snowmobile, 100 petabytes.
Yeah, they advertise Snowmobile as their exabyte solution. But people need 10 trucks to provide that.
Yeah, this number, I sometimes feel like they're not up to date. Like the training might not be up to date. So I would go in here and check actually.
Could be.
Petabyte. Okay, 100 petabyte.
Yeah, you need 10 trucks to get an exabyte.
10 round trip trucks. And the other thing, once you're in the cloud, then the proposition that AWS says is that you can use more advanced concepts like serverless applications or AI or machine learning that we've seen. They also have several APIs in terms of AI and machine learning, and we're going to take a deeper dive when we do the machine learning specialty for all of them. Cool. Last
question in the chat. Have you ever seen a company use Snowball? I haven't.
Snowball, no. I haven't seen Snowcone either. Maybe the videos have something.
Probably.
Cool. the last one is when you're building something. Remember when we went this path, right? And we're refactoring something and we're trying to figure out which application to put together. So one way to do that is through this AWS Well-Architected framework. And this basically is a checklist that you go through and make sure that it meets the different AWS best practices. So let's go quickly over them. So operational excellence, as you can imagine, making sure that things are running as expected. Make sure that you are developing code as small reversible changes. You have documentation, you're anticipating failure. So that's on the software side. Security, are you expecting unknown traffic? How are you handling user accounts? How are you handling encryption in transit or in place, in transit or at rest? Yeah, how are you handling all that? Reliability, how do you handle disruptions? Let's say something happens and you lose one part of your data or one part of your network. How do you handle that? Is your application available over multiple availability zones or even multiple regions? How do you recover from failure, basically? How do you scale? If you have a lot of demand, how do you scale on demand? And the last two are, is this an efficient way to actually build an application, as well as how quickly can you go global, if you want to scale to other regions, as well as, okay, I'm building this, but at the end of the day, I have to also keep in mind that we have a specific budget to keep in mind, and we want to do some kind of cost optimization for it. Yeah, so at the very basic, you're basically trading upward expense for variable expense. So in the data center world, you have to spend a lot of money, build your own data centers, maintain them, patch them, and then hopefully that was enough to meet your demand. Now you're just paying for actually what you use. You don't need to spend thousands of dollars when you're just paying for a variable expense. The other thing is you're benefiting from large economies of scale, like AWS is using all the servers that can give you a better price simply because of the scale. The other one is you don't have to exactly nail down the capacity. You can use and spin out services and shut them down as needed by applications and by your user demand. And the other one, you can quickly go to new regions. You can quickly increase speed and agility, as you mentioned here. So you can quickly experiment, like your dev team, with a new service or a new architecture, and that's really a huge plus. And then, yeah, I mean, we're not in the business of running data centers, so why should you spend money and energy there? So let the cloud provider handle that. And also, if you want to scale to other cities, other countries, other regions, you can do that, right? In going global as well. Cool. That was a lot of material. Again, the higher level is that there are multiple services. Each one of them has pros and cons. But there are pros and cons to just being in the cloud, as well as how do you handle cost and so forth. So I'll pause here before we tell a little bit more about what other resources we use for this certification. Okay, so this was this resource.
So George, one question I have is,
yeah,
the reInvent thing is going on right now, and they've introduced a whole bunch of new services.
Mm-hmm.
Has there been any indication if they're going to redo this course and exam based on that anytime soon, or have you heard anything about that?
I know they actually did the platform that hosts the training like a month ago, because I remember when I signed up a month ago, this will look very different. So I know the courses are different, the platform is different. I don't know if the content will update slightly based on.
Okay.
So there are two ways they can do this. They can either update, maybe something has changed in terms of like pricing or availability. I doubt they would introduce a lot of content here. This is like an entry-level certification, so I doubt they would do a lot of changes here. But yeah, in the other ones like solution architect or the specialty ones, I imagine they need to update it. Yeah. Cool. Okay, let's see. We covered this. Yeah, next week we're going to talk about the exam. I don't want to spend too much time about it now and spoil the surprise. This exam guide was very useful for us. We're going to cover that next week as well. Let's see what else did we use. There are some sample questions that we used as well that were useful before the exam. There were some webinars that you can take on your own time. There was an additional practice questionnaire that we took, but again, those are more on the exam side, which I want to cover next week. Okay. Awesome. All right, friends, I think this was great. More practical and more resources on exactly how to prepare for the exam we're going to do next week. This week, we just wanted to cover the high-level services and how they're used. We want to do this for other cloud providers as well. We're going to do this for Google Cloud and Azure as well.
So there was a question in the chat about sorry, it says, scrolling up. What areas do you deploy the most? And I was just wondering if you want to unmute yourself and tell us a little more about the question in terms of when you say areas.
All right, I didn't want to I was trying to type it. Are you using more about CPUs? Are you using more storage, more databases, applications, like EC2 instances? Are you using Kubernetes, blockchain, AI? Where are your specific areas that you focus on right now?
Right, that's a good question. So that depends on the company and the organization. So in my current company, we use a collection. So for example, our website presence is hosted on Elastic Beanstalk. Elastic Beanstalk is a way for you to manage EC2 instances and configure them in a way that they auto scale. So yeah, EC2, storage, S3. On my end, I use on the data side heavily relational databases, heavily serverless like Lambda, API gateway, S3 obviously. We use for data pipelines something called Glue, which is basically something similar to Spark that you can do any kind of transformations as you move data from one stage to the other. We use Athena a lot. Athena is basically an SQL query language.
Do you have a sense for how much money you personally are impacting your company for your spend on the cloud or your group?
Yeah, so within AWS has this nice feature that you can tag other different resources. So you tag them by project or by team or by department. And at the end, when you go to Cost Explorer, you can see a breakdown by that tag. So for example, if I tag them by department, like IT, HR, finance, not best practice recommended. I recommend you tag them by project because a project can span multiple departments. You can see a breakdown, and you can see a breakdown by tag, and also by the services they use. So if you use heavily Athena, you'll see that your project used, X amount of dollars.
So you see the architectural choices that you're making for different spends that you're using on the cloud then.
Exactly.
Therefore you're very sensitive to it then, hopefully.
Right, yeah, so when you go through the design phase of what is the application you want to build, you design it, you go through the cost exploration, and also you go to that 6 pillars of best practices. Is it reliable? Is it efficient? Is it costly optimized and so forth? So you go through all those checklists and you have an idea what to expect. And then not only that, but at the end of the month, you see what was the actual cost.
Thank you.
Yep, you're welcome. Yeah, I like these practical questions because you don't get to see them in the exam or in the tutorials. You know,
Most
if
of
you
this stuff
actually-
is very theoretical on, the way you're getting a certification. And most people only use only a fraction of where the cloud is.
Right. Yeah, again, there's like I said, 177 services. I use probably 10 or 20, 30 the most, but yeah.
I think that 177 services is a year-old figure too now, isn't it? It's over 200, I think.
I don't know. Yeah, maybe with reInvent, they announced so many new ones. Yeah, but you don't have to know all of them, right? Like exam aside, for your day-to-day job, usually you need a collection of everything, right? And what the cloud offers is compute, storage, networking, security. So you need 1 or 2 services from each component.
Yeah, as with any IT organization, usually you have people that specialize in one of those, not.
Yeah.
And so a whole, you usually don't have to know all of them just in a particular role. It's usually spread out.
Yeah, like usually IT handles all the infrastructure. When if it's the cloud, maybe spinning in services. If you're in the data engineering, data science, maybe you focus more on the pipelines and model building and deployment.
The exception could be when you're a very small startup and you're the only IT guy.
Yes,
And I have been through that in the past, and that is painful.
right. That's all the different roles and hats that you have to wear. Cool. Awesome. I like this session. It's different than what we've done, and it's more on the. Right now, it sounds theoretical. Hopefully, with the exam, it will become a little bit more practical. But yeah, as we do more projects on AWS and other cloud providers as well, it's very. It's something like if you've seen it, it's something they can easily relate to. And if you have never seen it, it's not that challenging to get on board. Okay. Then yeah, stay tuned, friends, for next week. We're going to actually go through the exam, what to expect, both in terms of the structure, how to prepare for it, and what resources we use. I'll stop the recording here, but I'll leave the floor open. For everyone watching us on YouTube, thanks again.